And then we'll just continue by expanding out this bracket here. So we end up getting, I'll just write it out here because there's 3 terms in that bracket. And I'll expand out this 3 into the bracket there. So I'm just going to expand this out, and then I'll be grouping like terms vertically to make sure, so it's easier to add up. So I have 3x squared plus xh minus 2x. That's expanding the x through those 3 terms in the second bracket. Then I'll take that h and expand it through the second bracket, plus xh plus h squared minus 2h. And then I'll expand this negative 2 into this bracket also. So we've got negative 2x minus 2h plus 4. And then I'll just continue on with this second bracket here. And of course that's all over h still. And then I can just add vertically to make that a little bit easier. So I've got 3x squared plus 2xh minus 4x plus h squared minus 4h plus 4. And then this stuff remains as always. And then I'll expand this 3 in, and then we can begin simplifying after that. And then when I look at when I collect all like terms and simplify down there, I will also factor out an h. So I have h quantity 6x plus 3h minus 12 all over h. So the average rate of change will simplify down to 6x plus 3h minus 12. Now when x equals 4, sorry about that, when x equals 4, the average rate of change, I substitute 4 into this and simplify, so we get 12 plus 3h. Then what I'm going to do is I'm going to come over here and I'm going to let h equals 0.001 for the following interval, and let h equal negative 0.001 for the preceding interval. So the average rate of change equals 12.003, and the average rate of change for the preceding interval is 11.997. Therefore, and finally, we have the estimated instantaneous rate of change, and that is the average of the 2 average rates of change with those small h values, and that gives me 12. So the estimated instantaneous rate of change of the function f of x equals 3 quantity x minus 2 squared minus 2, the function that we were looking at from the first page, at x equals 4 is 12. Okay, so then the next question here, why are all the rates of change for part A and now for part B, why are they all positive? Well, I'll do a quick sketch here, but the function, if we'll recall, is 3 quantity x minus 2 squared minus 2. So what form is that function in? And what can you find from that form? Okay, so we know that's the vertex form, and the vertex is 2, negative 2. Look at the lead coefficient. The sign of the lead coefficient, what's happening to that quadratic. Okay, so it's going to be opening up. And so then I'll just do a quick sketch here. So if I were to sketch this very, very roughly, we've got the vertex at 2 and negative 2, and it's going to be going up generally in this sort of fashion. Missed the 2 points there a little bit. But we see that in example A, one of the endpoints of the intervals for the average rate of change was x equals 2, and so any average rates of change were between points from 2 and over to the right. And I know I'm not hitting all the correct points from example A, but we're getting the idea here that noticing that all the rates of change are all up to the right, which means, or all the secants are sort of moving up to the right, which means all the slopes are positive. So it's because the average rates of change and the instantaneous rate of change, the estimate of that, were all taken to the right of the vertex where the function is increasing.